Hi, everyone. Thanks for joining us this afternoon. My name's Carrie Browsick. I am the agroforester and a senior natural resource specialist at Snohomish Conservation District, where I run an agroforestry program. And I'm here to talk to you guys today about wet feet farming, which is an application of agroforestry to adapt to certain conditions. And okay, there we go. Just to give you all an overview of kind of what we're going to talk about today here. I am going to address climate change in the Pacific Northwest. We're just going to do a real high-level overview really quickly, because that does set the context for why we are doing wet feet farming in the first place. We're going to talk about some of the farmer challenges that we are addressing with this application. We're going to talk about agroforestry and what it is and how it's used for adaptation. And then we're really going to dive into sort of what wet feet farming is, how we're using it, why we call it wet feet farming. We're going to talk about some of the farms that are applying these practices. We're going to talk about some of the crops, some of the plantings and how they were designed, some of the challenges, and then hopefully we will have time for questions as well. So let's dive in here. So just really quickly, and I know that probably most everyone here today has seen these predictions at some point in time. This slide here, the information you're seeing comes from the UW Climate Impacts Group. They are a great resource for looking at climate change predictions specific to our region. And so they've been doing a lot of research and modeling and things like that, and have come up with sort of these general predictions of the trends that our climate is sort of moving towards in the coming decades. And so what this is not saying is that from every year here, here forward that our climate is going to look like this, right? We're always going to have these warm winters and these dry summers. This is not saying that. It is saying that these are trends that we will start to experience, and we will start to experience these conditions more often as we move into the future. We may have a cold winter. We may have a wet, rainy summer. But these are the conditions that we're going to start to notice more and more. And we are looking, really, the trends are pointing to these warmer winters in general for our area. More water in the winter months. So it's interesting because the predictions are, for water resources anyway, are that the amount of water that we're going to tend to get is going to stay relatively the same that we're used to, right? So that annual precipitation that we are used to getting. What's going to happen is that that precipitation is going to come at us in a condensed time frame. So really, all the precipitation is going to sort of start to be condensed into these winter months, these early spring months, maybe late fall, right? So we're going to have a shorter window when all that water is going to kind of come at us. And then we're looking at sort of transitioning into these drier summers on average, with sort of some hotter temperatures and just these longer periods of dry where we just don't get new rainfall. With those warmer winters, of course, the precipitation that does come is going to be more in the form of rain as opposed to snow, which points to reduced snowpacks, which points to water running off the landscape a lot quicker, looking at increasing flood risks, looking at increasing erosion and landslides, and that type of thing, when all that water kind of comes at once, rushes off the landscape. And then sort of leading to then these water shortages potentially in these longer, drier summer months, because we'll have on average that reduced sort of snowpack that we're used to feeding sort of our rivers and our streams throughout the summer. So looking at potential, water shortages, reductions in water for irrigation, unfortunately, potentially, reduced quality of drinking water resources, water resources for recreation maybe not being super safe. So those types of things. Looking at increasing wildfire risk. I know we're used to those wildfire regimes on the east side of the state. There was a report recently put out that is talking about how wildfire risk is changing on the west side of the state, right here in our region, and what these changing sort of wildfire risks look like on our western side forests as well. We're looking at potential increases in insect and disease outbreaks, and this is in our forest lands, and also has potential impacts on our crops and croplands and farmlands as well. And then changes in tree composition and potential changes in sort of the appropriate crops that thrive in our region. So these are all, like I said, just a quick sort of high level overview of the predictions for the Pacific Northwest when it comes to climate change. And all of us are feeling some of these impacts in some way, right? And especially our farmers. Snohomish Conservation District, gosh, probably about 6 years ago now, did a big sort of project where we went out and we talked to a lot of farmers. We did some climate modeling. We did some testing of saltwater intrusion, and we called it the Ag Resilience Plan, right? And it sort of took stock of what our farmers were experiencing with a changing climate, what their challenges were, what their concerns were, and then we're taking that information and working towards solutions. And then too, as a natural resource planner, being out on the land with landowners, myself, my colleagues, we talk to landowners, to producers, to farmers all the time. And they express challenges that they're having on their landscapes. And we started to hear some general trends. One thing is that most of our farms, not all, but most of our farms are in lowland areas, right? They are in the floodplains. This is where the best soil is. It's where the land is a bit flatter. It's easier to cultivate. It's easier to graze animals there. So our farms are in these spaces. And traditionally, when they were put into these spaces, what we did is we went in and built in a lot of good drainage infrastructure, and we drained these lands so that we could cultivate them. And that has worked for a while, but as we're seeing climate change, as we're seeing changes on our landscapes, farmers are expressing challenges in these lowland spaces. And some of the common challenges that we're hearing are that upland development is increasing in our region. Lots of people moving here, lots of new housing, lots of things being developed in the uplands. And that stormwater ends up coming down into our farmlands. Another thing we're hearing is that there's upland clearing, maybe for timber, maybe for development, maybe for other things. And the runoff from that upland clearing is coming down into our farmlands. And we're getting these more severe rain events. And so all this new sort of climate pattern with all these things going on in the uplands exacerbates what is being received down on our floodplain farms. At the same time, that drainage infrastructure that they may have had in place years ago is getting older. It's starting to fail or it's in disrepair. So the drainage systems on their landscapes are not working as well as they used to. And it is also becoming very difficult, very costly, very time consuming, very bureaucratic to get new drainage infrastructure put into place or to repair drainage infrastructure. Regulations have changed. There's new permitting processes, and these things can be a real barrier to farmers, the costs and all of that. So these lowland farms are starting to take on a lot of water. They're experiencing, we're hearing things like, gosh, I used to be able to get my cows out into that back field, and now they just can't go out there. Or I used to get 3 cuttings of hay, in a season, and now I'm only getting 2, or I'm only getting 1. I can't go out and cultivate, X crop in a timely manner when I need to. I'm getting my equipment stuck, right? The soils aren't draining, they're not drying out. And so what they're expressing are these new emerging sort of wet conditions on their farms. And so there's a lot of solutions, there are a lot of approaches to addressing these concerns with our landowners. But one of the approaches that we've been looking at over the last several years is to come in and apply agroforestry into these spaces. And what is agroforestry? Agroforestry has a lot of definitions. I do like this one because it's quite descriptive, I think. So agroforestry really is a systems-based, sort of a multifunctional land use that really starts to combine a lot of things on one landscape, one parcel of land all at the same time. So we start to combine perennial crops with annual crops, for example. We may integrate forest plants in some way. There may be integration of livestock into these spaces. And these may be all at the same time, they may be sequentially in certain instances. And what you see highlighted at the end there are sort of the 3 main goals of an agroforestry system. When we design, when we manage these systems, we have these 3 main goals in mind. The first goal is to increase yields. We want our working lands to meet our needs, to provide us foods, medicines, materials, whatever it is. So certainly that is a goal of agroforestry. But we also have these other goals, and those are to realize ecological benefits and to maximize ecosystem services as well. And all of these goals are co-equal in the design and the management of an agroforestry system. And I do have to say that agroforestry is nothing new. Agroforestry systems, agroforestry as practices have been used by indigenous peoples around the world for thousands of years. There's evidence of agroforestry systems all over the globe, and certainly there are peoples today that use agroforestry systems all over the globe. Certainly here, in the Pacific Northwest, the indigenous people here used forms of agroforestry for thousands of years. What is new about agroforestry is the terminology. What's new is maybe some of the equipment that we have now. What's new is the growing body of scientific research around these practices, but these practices themselves are nothing new. They have thousands of years of human history and practice behind them, and knowledge, certainly. And I do point to a study here that's interesting if you're curious about some of these systems found here in the Pacific Northwest. And what's cool about these systems that they've been studying is that not only did these systems, these agroforestry type systems, meet the needs of the people that tended them, but they also provided this amazing ecological enhancement, these ecological benefits to the environment that they were tended within. So again, bringing in those co-benefits of some of these types of systems. Agroforestry is being studied a lot for its potential to sequester carbon. So I started talking about climate change. Agroforestry is being seen more and more as a nature-based solution to climate change. I know we've all been hearing terms like carbon farming and things like that, regenerative agriculture, and certainly agroforestry falls into those buckets and is being studied for its potential in this space. This is a study that was put out several years ago looking at different land management practices and their potential for carbon sequestration. So that those numbers we see on the left-hand side there are showing gigatons of CO2 per year, per acre for these different land management systems. And we can see that grazing management's got great potential there, forest management, and then we start to get into agroforestry. And the authors of this study did point out, and I don't love to read slides to people, but I am gonna read this quote. With even a modest level of adoption, agroforestry could sequester 2.2 gigatons of carbon per year, more than any other agricultural land management approach out there. How much more carbon could we store if agroforestry were widely adopted? And this slide you're seeing here is sort of a global look at the potential to adopt agroforestry and its potential to sequester carbon. To bring it down to more of a local scale, this is a graphic that was put together by Dr. Lynn Carpenter Boggs from WSU. She works in the soil science department. And she was looking at the adoption of agroforestry for Washington State. So again, we have those numbers on the left represent gigatons of carbon sequestration potential. We have different types of farming practices along the bottom. And then what she did on the right-hand side there is she represented different counties in Washington State. Why did she do that? Because these different counties represent different types of climates and different types of soils. And the climate and soil and those types of things impact the amount of carbon you can sequester and store in some of these systems. So we can see, we have things like cover cropping. We have that rotation there is for rotational grazing. That actually looks quite promising. And then we start to integrate trees, and we can really see the potential for that carbon sequestration. So when we're thinking about climate change and we're thinking about land use and we're thinking about farming and how we're meeting our needs, we can see that the integration of trees, practices around agroforestry really have potential as part of a solution to climate change. But they do not only offer a solution, they also really are a great tool for adaptation. And that's what we're getting at when we're getting into wet feet farming, is not only as part of a solution, but as real adaptation to real on-the-ground problems. And this is a graphic that was actually put together by NRCS, and it shows risks from climate change. It shows adaptations in the middle there that you would need to address those risks. And then on the far right-hand side, it shows agroforestry practices that would give you the adaptation you need to address the risk that you're facing. And we can see just that first one there, intense precipitation events. This is something our farmers are talking to us about. What kind of adaptation do we need for that? We need to slow that water down. We need to slow the runoff, reduce flooding. Certainly, our farmers express concern around flooding. We need to reduce soil erosion, and we need to address water pollution from these events. And then we have these agroforestry practices that we can utilize to give us these very adaptations. And we can see here riparian forest buffers and alley cropping are what are the practices that NRCS put to address these concerns. So a really cool kind of chart. This chart is much bigger than what you're seeing on the slide, but really pointing to the use of agroforestry practices to adaptation. And so we sort of took that to apply to a lot of these concerns that we were hearing from our farmers. So really taking agroforestry as an adaptation to these lowland farms and to these concerns about these new emerging sort of wet conditions that were showing up in spaces on some of our farmlands and were reducing production. And so instead of going down the road of putting in new drainage infrastructure or repairing drainage infrastructure, which still can be done, it's not that it can't be done. It creates a lot. There are barriers to certain landowners that can't navigate that. Instead of doing the drainage route, we're coming in with agroforestry and we're saying, well, okay, we're getting all this new water onto these landscapes. This water's creating these new conditions. What can we do with perennial plants, with these new types of systems, to bring production back to these spaces while still allowing these landscapes to hold that water instead of draining it off, right? Because too, we have to consider that in the first slide I shared, we're also headed towards these regimes of these long, dry summers as well. So finding these balances on our landscapes, do we necessarily want to take all these great water resources that we're receiving right now, drain them off the landscape as fast as we can, and then as we face those long, dry summers, well, now what do we do as our soils start to dry out, right? So can agroforestry create a system where we can accept that water, we can hold it on the land, we can still have production, and we can actually have those water resources longer in to those long, dry sort of summer type spells. And so I already talked about this, sort of working with the new emerging conditions on the land by bringing in these perennial crops that are suited to the specific conditions that we're facing. And so this is what we did with wet feed farming. And we got funding through WSDA to design these systems and to plant them on some farms in our region and to collect some data and sort of test them out. What we did is we selected 3 main crops to insert into these systems. And we selected these crops because of their abilities and their sort of hardiness towards these variable conditions on our farms. So aronia berry is one of the crops you can see there that we selected. I kind of think this crop is really sort of a climate change superstar. It's very hardy. It's very productive. It tolerates a wide range of conditions. It's good for pollinators. It can be saturated. It can dry out some, and it produces these berries that are really growing in interest, and there's emerging markets for these berries. They're being touted as a new superfruit. And they make amazing wines and medicinal syrups and preserves and all types of things. So that was one that we selected. Cider apples. Now, commercial apples tend not to do well in conditions like I'm describing, right? These wet, saturated conditions well into the spring, ponding, then really drying out, right? But what we've done here for this crop is we've taken our native Pacific crabapple, Malus fusca, as our rootstock, and we've gone out and planted that into these selected farms. And then we've come back and grafted more commercial varieties of cider apples onto that native rootstock. And what we're finding is that there's a lot of varieties that can thrive in these sort of harsher conditions when they are grafted onto our native Pacific crabapple rootstock, because our native crabapple is quite hardy. It can tolerate these types of conditions. So that when I have cider apples up there, that's what's going on with the cider apples as a crop. And then the third one was willows, basketry willows, ornamental willows for crafting markets, for ornamental or for floral markets. We worked with some local producers to select hardy varieties that they know to thrive in our region. And this was the third crop that we offered to our farmers. Now, in addition with these three crops, we allowed our farmers to diversify their plantings further if they saw fit to do so. And so some of the crops that you see here reflected are some of the varieties that our farmers chose to integrate into their systems. And we have everything from gooseberries to hazelnuts to native seed, to quince to evergreen huckleberry, and there's more. This just is a representation of some of the variety that farmers integrated into these systems. And so I want to talk a little bit about the farms. So the first farm, in this grant, we had 4 farms that chose to participate. One farm in Snohomish County, a farm in Skagit County, and 2 farms on Whidbey Island. This Rooted Northwest farm is here in Snohomish County. It is a 250-acre diversified farm with co-housing. Up until very recently, until like the last 5 years or so, this was an old dairy farm, and most of the ground was in hay and corn silage rotation. The problems that they were facing on this farm, as Rooted Northwest bought this land and started transitioning to other methods of farming, was in sort of the back acreage, they were experiencing failing drainage infrastructure that was old and just wasn't useful anymore. They were experiencing a lot of reduction in their hay production in that space. It was very hard for them to get equipment out. So those very conditions that I'm describing, this farm had those conditions on some of their land. Now, it's not all their land. There are lots of areas of this farm that are in great condition and not experiencing these things, but there are areas that are. And so for this farm, this is the planting that we designed. We did a 3-acre planting in this problematic area. We did these mixed species rows and we planted them in alleys. So the agroforestry practice that we're using here is alley cropping, We're planting rows of perennials. And then we have these wide spaced alleys. And the alleys in this planting are spaced at 30 feet. Why? Because as this space transitions into a more perennial system, the farm is still cutting hay within the alleys. And whatever the conditions are for the year, maybe they get one cutting. I think the year we planted, they were able to get one cutting. On a good year, they get a couple of cuttings. But for now, in the alleys, they are still in hay production. The dominant crop that they chose for their planting was aronia berry. And then they mixed in these other species that you see here within those rows. And all the plants you see here, except the clover, which was just in the understory, those were all at a 6-foot spacing, so planted relatively tight. And then, like I said, hay production within the rows. This planting went well. After the first year, we had, oh my gosh, like 98% survival of the plants. So the plants that were chosen they thrived, they did well in the conditions. The main challenge here was deer browse. Deer came in here and they found that those aronia berry and they were just in heaven. And they chewed the aronia berry down. Now, aronia berry is hardy and it survived the deer browse. But that is certainly a huge challenge here with getting these perennials established. And so in round 2, we're going to be coming back in and we're going to be putting up some 3D fencing to discourage the deer from coming in here so that these plants can get established. Now, as these plants get bigger, as they start to spill out into the alleyways, as they start to cast some shade and things like that, this farm's intent is to transition what's happening in the alleys, which is currently hay production, into shade-tolerant herbs and medicinals and things like that. So this is a system that's in transition into a different type of perennial system. Also up here in this picture, and I assume you all can see my cursor, you see this little square. They did also integrate the basketry willow. They wanted to manage that willow in a different way than all these other crops. And so by doing coppicing, right, stool coppicing. And so they planted a little square up here of that willow. They did put deer fencing around that, so that willow is thriving. They are able to coppice that, and that is in a particularly wet, mucky spot of the farm, and that willow is really doing well. So this is an example of one of our farms and the system that they designed to meet their needs with this perennial, with this wet feet farming. Northwest Meadowscapes. This is one of our partner farms on Whidbey Island. The main production on this farm is native seed. This gentleman is a biologist that works for Xerces. He has amazing knowledge of native meadow plants, of insects, of songbirds, and he also likes to farm. And so he bought this farmland. And this was a 15-acre piece of farmland that he bought. It was originally wetland. And about 100 years ago, a family came in and they put in drainage infrastructure and they farmed this piece of land. I think the history was cattle, it was hay, it was basically mostly beef production throughout the history of that. There may have been some dairy at one point, if I remember right. And then this gentleman bought this piece, and again, the infrastructure, the drainage infrastructure on this piece of property is old, it is failing. And so this land is sort of converting back into these very, very wet conditions. The description here says that this is a 15-acre orchard and native seed farm. And yes, he does native seed production, but really his dream was to have an orchard. And it's very hard. You can see his picture here with, this is an old apple tree, growing in these, you can see these wet conditions that start to occur. And he, ended up with this piece of land and he could not grow apples. So he took the native Pacific crabapple rootstock and he started to graft cider apples to it. He did an amazing SARE study quite a few years ago and tried all different varieties of apples and pears grafting to this native rootstock, and has great documentation of the varieties that thrive and the varieties that don't do well. And he created this orchard and then continued to cultivate this native seed in the alleys of the orchard. So again, taking the conditions of the land that were there and adapting to the conditions of the land is what this gentleman did before we even partnered on the grant. When we partnered on the grant, he had established his sort of orchard space and his native seeds. But there's this drainage, and you can see folks along a strip here, and the orchard is kind of up here at the back of the property. And all this water runs down this way. In the winter, in the spring, it gets super saturated, super mucky. And all the water dumps into this surface water that you see down here in this picture along the road. And there are also some adjacent drainage ditches as well that run to the side of this farm as well. The bay or the ocean is literally just right off to the right of this photo. And so typically when we're out on this farm, Fish and Wildlife are also out on this farm, looking at these surface waters, documenting the fish they find in there. So we came in, and with this strip of these really wet conditions, and these conditions are in this open space here, he's got open space seed production for more sun-loving meadow type plants. And so the wet, mucky conditions were impacting the rest of this space. So we came in here, and what we did is another wet feet farming practice. We came in the form of an incredibly dense hedgerow planting of all kinds of native plants. And we planted that in to address some of these wet conditions, to act as a filter for some of that water, to act as a way to catch some of that water, and to also be productive. And this gentleman integrated cider apples, again, grafted, the aronia berry, and then we integrated a whole diversity of species that fed into his native seed business as well. Diversified the hedgerow, made it incredibly beneficial to insects, to all kinds of wildlife, but also fed into the business. In his alley cropping system here, as these trees get bigger, in the rows, he's right now doing a lot of sun-loving native seed. But as those trees get bigger, he will be transitioning to more perennial herbs, maybe shade-loving native seed species, those types of things. So again, a transitional system that he's got. The challenges on this site with the planting. Again, not the establishment of the plants. The plants did very well. We had very, very little plant mortality. The challenge was the deer browse. If anyone finds the magic bullet to deal with deer, gosh, you could make millions. Deer are such a challenge when you're planting any of these systems. And so again, we in sort of round 2 with this farmer, we are putting in some deer fencing and things like that so that these plants can get established, they can get up, they can start, the apples especially can start to be productive for this farm. Bell's Farm, a 65-acre multi-generational farm on Whidbey Island. They do multi-species grazing. You can see a lot of their livestock in the back here. They have cows, they have sheep, they have pigs. They grow strawberries. They do a big strawberry festival every year on the island. Lots of types of production on this farm. They have this area of the farm. You can see the farmer standing here with these really wet conditions, super low production in this space. It just because, it's just really a loss of production and a space that this farmer was really excited to diversify. Soils are saturated late into the spring. He cannot get out and cut hay. He can't really get his animals in this space. And then these soils dry out quite significantly in the summer. And so really, he was really looking for ways to bring, and this, you see him standing here, and I'll show you in the map at the next slide here. So this space kind of wraps all around this irrigation pond that he has, and he was very excited to figure out a way to bring some of this space sort of back into production. And so we did here a 1-acre multi-species planting. The design here was in rows. And what you're seeing in this sort of little rudimentary drawing is these sort of green blobs represent our trees. These fuzzy little salmon-colored things actually represent an interseeding with California oak grass. And this is because the farmer is going to graze his livestock through here. Once these trees are established, he will put up hot wire, he will put up some electric netting and protect these trees, and then he will run his livestock through these alleyways. So we in-seeded some forage in here, and then we diversified with some natives such as beaked hazelnut and black cap raspberry, which is a very wily plant that does all kinds of crazy things. But the farmer wanted the black cap raspberry as a berry crop and as something that some of his livestock like to chew on. So we interplanted some black cap raspberry. And then these little blue dots you see at the edge of the pond here are basketry willow. They have a farm stand on this farm. They sell cut flowers and things like that. So the basketry willow fit in very nicely into their model there. The challenges at this farm were not deer pressure. They did not have deer pressure here. The challenges we had here with our planting, and we did have about 50% mortality of our plants. And the reason was that this planting got done relatively late at the beginning of April, which is quite a late time to plant. And then if you remember, it got pretty warm and pretty dry pretty fast. And now this is an irrigation pond here, but of course, the pump broke. And it took quite a long time to get the irrigation pump fixed again. And so like the willow for sure, they perished. So, and then there is a little bit of vole pressure here as well. So in round 2 at this farm, we came in, we replenished that die off and replanted those plants that perished. The farmer has been able to fix the irrigation pump. We came in and did the grafting onto that Malus fusca rootstock, and this planting is ready to go. And the last farm I'm going to talk about, and I'm not sure what my time is here. I know it's getting late, so I'll speed it up. I'm almost done. The last farm in our grant here was Bow Hill Blueberries. They are a 6-acre organic blueberry farm. They do a U-pick, and they have a great value-added products business. I'm sure you've seen Bow Hill blueberries in your local store or at farmers markets. They're kind of all over the place. They have an ice cream. They've just got great products out there. Here in this picture, you see some of their blueberries. At the south of the farm, there is a water course that runs, and in the winter months and the early spring, this water comes up. It floods into the blueberries. It can impact the blueberries here. It saturates this ground well into the spring. It causes some problems. So they wanted to put in essentially a buffer here of plants to help buffer their berries and to help deal with some of this water. And so the dominant crop they chose was aronia berry. Made sense. It feeds really nicely into their value-added products business. And then they incorporated a lot of other natives to diversify this hedge planting and make it very dense and benefit wildlife, all while also producing a product for the farm. The challenges here have been relatively little. They have not suffered deer browse. The plants have survived quite well. They are actually gearing up to do a tour of this planting and talk about this planting in the spring. I think it may be late April, early May. So keep an eye out for that. So this we're not really doing a round 2 here because they've had very little challenges with this planting so far. I think probably a round 2 with this planting could be maybe, building in some more density if need be. So talked about climate change, talked about the challenges, talked about agroforestry for adaptation, talked about wet feet farming, talked through the farms that have participated in this sort of experiment. What are some of the next steps? Our funding is coming to an end. We have a lot of great lessons learned. We are, as I mentioned, we are starting to have farm tours at these farms where the farmers get to talk about the planting, talk about their experiences, their challenges, what they've learned, what their tips are. We are coming out with a video that will be released in the fall, so watch for that. And we are creating a guide from these plantings with the help of our farmers that will really be a guide that someone can pick up and really look at to do some planning and some design for one of these systems, maybe on your own land. To look at, it will talk about the crop profiles that can be put into these types of systems. It will give resources such as marketing resources for the crops, nursery resources, and resources for technical assistance. So that'll be a great useful guide that will come out of this work so that people can take that and maybe do some of this on their own property. Just to summarize everything really quick, we are dealing with climate change in our region. Producers are certainly feeling the effects of climate change and of development and of different regulations, and all of these challenges are converging on our farms. It's not just climate change. Agroforestry is a tool that can help mitigate for climate change, and it can also help landowners adapt to all these different changes that are occurring on the land around them. Wet feet farming is an attempt, it's one of those attempts to use agroforestry to adapt to specific conditions that our Pacific Northwest farmers have been facing and expressing. While there are challenges to these plantings, we're learning from those challenges. And these practices, I think at this point, are showing a lot of promise. I think agroforestry could be applied to a lot of other types of conditions as well. And I'm excited to find out what that looks like as we move into the future. So with that, here is my contact information. And if we have time for questions, I am maybe a tiny bit of time for some questions.
Yes, that was fantastic. Thank you so much, Carrie. You explained all that so well. Um, we do have some great commentary in the chat that I'd like to get to, but for the sake of time, we have a couple minutes left. I'll address some of the questions in the chat first. So, um, a question earlier in the presentation, any ideas for strategies that those of us who farm on leased land might be able to use? Are there agroforestry strategies that make sense without long-term land tenure?
Leased land is a big challenge in the agroforestry world because these are perennial systems. These are systems that need time, certainly time to be established. Um, if you were going to do something in the shrub world, things like currants, things like elderberry, things like aronia berry, these are all perennial crops, things like the ornamental willow that are quite productive in a short amount of time, right? So establishment and production, you're really looking at 2 to 3 years for really getting into good production. So I would recommend that if you're on leased land, those are the types of crops. If you're getting into more treed crops that are going to take that 5 to 10 year time frame for establishment and good production, then that is where we run into these challenges on leased land. And there are all kinds of people out there trying to figure out what long-term leases might look like with different types of landowners. So certainly if you can finagle a long-term lease, that is really where you're going to have to go if you're going to approach any type of tree crops on leased land.
It looks like some people have put some information in the chat related to that question as well. So please, if you ask that question,
Yep,
go ahead and take a
long-term
look.
leases. Yep, these are great resources. Yes. Long-term leases for agroforestry. Yeah, there's a lot of people creating models out there around these things. Yes.
Perfect. Thank you. And I just want to get to some of these other questions real quick. Earlier, when you discussed sweet gale as being an option for planting, someone asked, can you discuss how well sweet gale has worked as a nitrogen fixer in the system?
Yeah, and so these systems, it's hard with agroforestry systems because we are always working with like 3-year grants, right? And so your first year, you're lucky if, I mean, usually you plant at the end of the first year and then you've kind of got 2 years to look. So I wouldn't say, I mean, we have been taking soil tests and things like that. I don't think we have a lot of data within the timeline of this grant to show anything really specific to the nitrogen fixing of the sweet gale. It has survived as a plant, but I feel like, and we are thinking about doing another round of this funding to take these systems and explore that type of data further. But yeah, at the moment, I don't think our soil samples really show anything significant around that. Just with more time, with a few more years, more establishment, who knows what we might find. But right now, yeah, nothing to report.
Right. It's 2 o'clock, so I'll just ask one more question because a couple people had this question. What varieties of willow for the baskets were you guys using?
Yeah, I would, gosh, I would have to look that up. I want to say we have about 15 different varieties that have been. We worked with Dunbar Gardens up in Skagit County. They're a great willow grower, and they've grown willow for years. And the gentleman up there was very informative about what species to really key in on for our area. I don't have those off the top of my head. I have them documented. I can send that out and follow up with folks that are interested in that. But yeah, yes.
Perfect. Yeah, we can certainly do that. So it is 2 o'clock. We can go ahead and follow up email with any questions that we missed, and maybe even share those willow varieties once we have that information. So um, put any last minute questions in the chat, and we can get that addressed in the follow up email. But otherwise, Carrie, again, thank you so much. That was fantastic information, and
Yeah.
um, you guys have a great rest of your day. Thank you
Thanks,
for watching.
everybody.